for a second. My walk around.
No, they will.
Okay, so chapter 3 is kind of a weird chapter because it incorporates, it's about power, but incorporates a bunch of other different stuff at the same time. Okay, so we're going to first introduce the non-power stuff, talk about not power, and then we're going to talk about power. Okay? Catch your notes. So, this chapter is about electricity and power supplies, but we're going to talk about some other things first to kind of define what you see. Okay? So, the first term we're going to talk about is form factor. That's a term you have to know. It'll be on the test. It's going to define things for the whole rest of the course. Okay? Form factor describes the size, shape, and general makeup of a hardware component. Okay? PCs, motherboards, cases, power supplies, which is why it's being introduced here, have specific form factors of things that go together. To understand form factor, it'd be like if I said Max had a Chevy Nova, okay, and Austin has a Lamborghini.
Dang it.
And Max wants to put the Lamborghini engine into a Chevy Nova. Is it gonna fit? No. Can you just take an engine out of one car and drop it in another car? Some cars, if they're both Chevys, have the same engines, and you could, because they have the same form factor under the hood. Some cars have completely different form factors. Nothing would line up and you could not do it. Okay? So that's the idea of a form factor, that there's a size and shape to things to make them go together. Just like you can't pop one car engine out and throw another car engine in, you can't pull out one motherboard and necessarily throw another motherboard or power supply in. Okay? Form factors of the motherboard, power supply, and the case, those are the three most important things, have to match. Everything else doesn't. I can take the CD-ROM out of this PC and put it into this PC. I can take the memory out of this PC and put it into this PC. Everything else still has form factor, but it doesn't have to match the power supply in the case. It only has to match the motherboard. Everything else just plugs into the motherboard, but the power supply, the case, the motherboard all have to match in order for them to fit. Generally, the motherboard drives the decision. We decide what kind of PC we want to make, and we buy a motherboard that will do that, and then we have to buy a case and the power supply, and the power motherboard, and the stuff we want in it. But the decision starts with the motherboard, which is why the first research paper you're going to do is on motherboards. You're going to research and present 3 motherboards, and all the rest of your presentations from then on are going to have to plug in to the motherboards that you presented in chapter 4. Okay? But you guys are going to make those decisions. Okay? And those decisions determine everything else that comes after that. And the form factor of the motherboard determines what kind of CPU you can get, determines what kind of memory you can get. So you have to know what your form factor is from the beginning of different kinds of things. Okay? So, we're looking at form factors. Apologize I didn't clear this out. Things that have to match. The motherboard has to fit the case. The power supply has to give the correct voltage, have the right kind of plugs. The motherboard. And it has to fit the case. Holes in the motherboard have to align so that you can screw it in. Or you can't just lay a motherboard inside a case. All the way it connects has to align. Okay? And we have a bunch of connections that go to the motherboard from the case, like the power button. If I don't have the right kind of connector for my power button, it no turn on. And one of the definitions of a successfully made PC is that it actually turns on when you're done, not just it's screwed together. So, form factor defines all these things, and as we get into each one of the components, we're going to talk about the specific form factors of that component. But right now, we're talking about cases, motherboards, and power supplies. That's why it's introduced in power supplies, because you wouldn't really be able to introduce it later. So when I look at a motherboard, there's a couple different form factors out there. Actually, there's a number of form factors out there. Baby AT or AT form factors in general are gone. Everything here at National Trail fits into these two categories, pretty much. They're all ATX or BTX. other ones are all proprietary ones that make very specific systems that we're not going to really worry about. We're only going to worry about ATX and BTX form factors. And of those, the one you're going to do your project on is ATX. ATX has been around for a long time, since 1995, introduced by Intel. And at one point, other manufacturers tried to introduce BTX, and I will say, in my opinion, it failed overall. So everybody's still pretty much using ATX. Okay, so the one we're going to use is ATX, although we have BTX. And if we look at the pieces behind you, one of these is ATX and one of them is BTX. This is an ATX case. Dell's, to a large extent, not all, okay, use BTX. What's the difference? Look at them. No, not really. This is the ATX. That just happens to be this one. There's different sizes of ATXs and ATX. They're a mirror image of each other. Okay, here's the front. Here's the front. If I look at the back of these, motherboards are on a different side. There's no way you could put this one into that one. It's on the wrong side of the PC. You can't just flip it over. Okay? So that's the biggest thing. The power supply is the same, it's the exact same power supply. ATX power supply, BTX power supply, doesn't care. It screws in the exact same way, the plugs are exactly the same. All the components inside this PC can go into this side of the PC, except for the motherboard. Because the ATX motherboard won't fit the BTX case. This ATX motherboard has a pop-out cover for the motherboard plugs. It comes with the motherboard, so you can put any other ATX motherboard that comes with a cover plate inside this ATX case. This BTX case from Dell, this is welded in part of the case. The only other motherboard I can put in this case is the exact same motherboard. I couldn't put any other motherboard inside that case and have everything line up. Okay? Which is maybe why Dell does it. You can't just easily upgrade or replace theirs. You have to buy a whole new one. You don't like theirs, you buy a new one of theirs. Here's one old. Whereas with this one, if I have this computer right here, I want to upgrade it, I want to just buy a new ATX motherboard, I can just buy a new ATX motherboard. Unscrew this one, take it out, maybe use the same CPU fan, a different CPU, same memory. I can almost use everything on this PC over again for full upgrade. This one, I can't use the biggest component, which is the motherboard and the case. I have to start all over. Okay? So, your research project's all going to be ATX. I just want to point out that we have BTX. The only difference to you when you go to hook one up or go to look at one, that's the best. There we go. The only difference when you look at one is that it's reversed between ATX and BTX. It's like mirror image of each other. Okay? And we just walk up to one. Yeah, I don't necessarily remember which one which. Except for I gotta open it from one side and one side on the other side. Okay. Okay, so we got ATX and BTX. When we look at a motherboard, I'm going to go to the next picture. We look at a motherboard, we have a standard power supply plug anymore. Okay, this is the old AT power supply plug. We have a 20 or a 24 pin power supply. What that means is this plug right here could have 20 or it could have 24. When I buy one, look, my hands. Now it's 20. So if I see one that says it's 20/24, it means it can be either one. If I see one that says it's 24, it means it's only one. This is a 24 pin Dell power supply. There's no sliding off of anything. We'll only work on another 24 pin computer, which is most of them anymore. Most of them are 24 pins. Okay? Both of these power supplies will power the same PC. Will they fit in the same computer? No, they're the wrong form factor. Okay, so although this works, has the same plug as this one does, has the same voltages on it as this one does, it won't work. That's because it's the wrong form factor. Okay? So we've got this plug that plugs into the motherboard. It's called the P1 plug. Okay? So it plugs in there on the motherboard, and it provides the majority, not all, power on the motherboard. Okay? I also have another plug over here that was added when we went to Pentium 4s because the processor requires so much more power. So if I don't have this one plugged in, it goes right here, it will not start. It will act like it's going to start, and then it will fail the CPU check on the post. You may not get any beeps. I may get a beep. It's kind of questionable. That's why I gave partial credit for the one that said the CPU will beep me, okay, or the power supply will beep. So, but if it's not plugged in, it's not going to complete the boot process. Some of these have 4, some of them have 8 plugs on them. Okay, so that's what's required to get the CPU to boot, or the computer boot. It's these 2 powers. The rest of them, it'll still boot, at least the BIOS. Okay, the rest of these we can cut them off and it will still boot. You may not get an operating system. Okay, so those are the power plugs that are connected to the main ones that are connected to our PC. ATX is the most common. It's been around since 1995. That doesn't mean it's the same motherboard. It just means the form factor stayed static since 1995. The holes stayed in the same place. When we moved to AT, from AT, which was the old one that I started out with, to ATX, they moved the CPU and memory to avoid interference with the expansion slots. In other words, all ATX look like this, in that they go back panel, CPU, memory, and all the expansion slots are on the side. And the difference between this one and a bigger one is just this stuff can have more out here, which is why that one is much longer. These are both ATX. That one's a lot longer because it has a bunch more slots. It has 2 high-end video card slots. Okay? This at one time was a good gamer case. Okay? But it's bigger, but it's just because it still goes back panel, CPU, bigger CPU, and memory, just like this does, back panel, CPU, memory. All the expansion slots are down here, so they're out of the way of that stuff. And that's how I can have the same holes work the same one, because I just extend down and then I get more holes. These basic holes right here, this one, this one, this one, and this one, are the same on all ATX. And then if the case gets bigger, I get holes here. If it gets bigger up here, I add more screw-in holes here. I'll show you a picture of that here in a second. Okay. Power supply uses a single P1 connector, and with ATX, the power supply always blows air out of the case. The air is always flowing out of the power supply, which means if the air is going out here, what should that be doing? In or out? Out, because we want an airflow that goes all the way through the case like that to cool the case off. This is Cindy's PC, we just upgraded there. Okay, and were you in the class when we did a scan on it? It was overheating?
Yeah.
Well, I know why it's overheating now. This is blowing out, this is blowing out, this is blowing this way. This CPU fan is 180 degrees out. It should be blowing that way, so all the air comes across the CPU, that the cool air is coming across the CPU and blowing out. Instead, it's blowing the air across it, so it's blowing hot air here, and it's just kind of circulating in those where computers get so hot. I didn't know that until I had it open. I was like, whoa, and I'm probably the dummy that put it in backwards. I just didn't realize which way I put it in when I did it, I guess. But it's supposed to blow out the back of the case. Okay, this is what I just said just a second ago, that I have my back panel, CPU, a bunch of different kinds of CPU sockets, we'll talk about that later, and then memory, and then all this other stuff is where I can get bigger and bigger motherboards by adding more things onto my motherboard. But this back panel is all the same size in every PC. You can't get any bigger than this because it has to fit in this slot. But you have motherboards that are exactly that big. That's as far as they go. Everything's integrated. There's not a single expansion slot, so you can have a PC that's literally that big. Which I have one up there. See that PC right there? In that box, that is a PC right there. The kinds that are at the cafeteria stations, those are full PCs, right? And they're only exactly that big. It's all built to be inside. So when we look at motherboards, we can Pico is the smallest, then Nano, then Mini, then Micro, then normal size. And basically all they do is take the same set and then they can extend it bigger and bigger and make it bigger and bigger. But it still would be ATX if it fits the first set of holes and then any set of holes after that. So you could always put a Micro ATX ATX in a full-size ATX case. You just couldn't put a full-size ATX motherboard in a micro ATX case, obviously. But it's made so that those basic holes, these would be the first 4 starting ones, and then you get bigger, and then you get bigger, but they all line up with the same starting point in the case, okay? And I already said this twice. I don't know what that was. I hit something else. There were back panel stuff, CPU socket, however memory slots, and then all the expansion stuff goes below that so that it's out of the way of everything else. So I can use a really long card and it won't matter. Okay, to go all the way back to the case, which we have some that are that long. I already saw it, it didn't matter, did
I was
it?
like, it's AC/DC.
No, what's wrong with my little clicky? See, this is what I need to do is have this up, that, when I go to the page, then it wouldn't do that, would it? Dang. When I do it like this, I need that band, okay? So I gotta save it like this when I'm done. And remind me so that it's not much less than huh? You can see it when I went through this
But
slide.
why is it on the
Yeah,
slide?
why? Because we're talking about AC/DC next. We're talking about electrical power, okay? Those are my segue transition between motherboards and electrical power. So electrical power is AC, and electrical power is DC. AC power is the kind of current that is the most efficient to transmit. It's the kind that comes out of our wall. If I ask you, I plug into a wall outlet, is AC/DC power on the test? You would say it's AC. Wall outlets are all AC. They cycle back and forth at 60 hertz or 60 cycles per second. Alternating current alternates back and forth at 60 times per second. Our wall outlets are 110 volts, right? Way too high for the inside of a computer. Transformer rectifier. I could not think of that word last class. Now I have to write it down.
Wait, what'd you say? Alternate current is in all.
I have to write down transformer rectifier before it goes out of my head. Literally stood here in silence for 5 minutes. My brain would not think of transformer rectifier. We'll talk about what a transformer rectifier is.
Like you said, they put in our school everything.
Every outlet is 110. Everywhere. Okay. And they oscillate back and forth at a rate of 60 hertz. That's our regular electrical power here in the United States. 110 and 60 hertz. Okay. Because it transmits best. In Europe, it's 220. Okay. Which is why power supplies in the back have little switches say 110, 220. So I can make a PC here in the United States, and all you have to do when it gets shipped over there is go boop, and plug it into the wall. It still works. Okay? It's also why if students go and change that switch to 220, the PC doesn't work anymore. We walk in there and all we have to do is go like this. It's also why we have all of these power supplies, because when we got them all in, they were all set to 230, and somebody that is over in 209 closet said all the power supplies are bad, so I bought a whole new box of them, and then we realized that all of them had just come from Germany, and that's why they were all, I'm not saying names, so they were all set to two, actually this one says 230 and 115, that one says 110 and 220, but they were all set to the wrong thing, because the PCs all we got from the Air Force had just been in Germany, they're all set for there, none of them worked. Why is it different?
It's just how it is.
That's how it is. I don't know. That printer right there is a 220 printer. It's from Canada or eBay. So give me the money back. Give me the money back and say just throw it away. I'm actually going to try to change it.
So you're free if you can get.
Well, the other part that I had to buy cost $900, so we'll see. The part is if I can change. Anyway, so AC is what's transmitted. DC is what we need. And we have a power supply our power supply unit, you'll see right PSU for power supply unit. Okay, so you're gonna see me write PSU, but it's the power supply unit. And I'll leave that up there for since M is not here. And it turns 110 AC to DC. So first, it's a transformer rectifier. First it transforms, first it rectifies AC to DC. That's what a rectifier does. And then it transforms 110 to 3.3, 5, and 12 volts. That's what our buses are inside power supply. Okay? It's a transformer rectifier. Okay? Out at your corner where you live, there's a big huge transformer on a power pole, right? It transforms the power down to 110 because it's not set 110 through the big power lines. It transforms the power from whatever it's actually transmitted from the power company down to 110 to come into your house, which is why the power line in your house doesn't kill you nearly as well as the power line going to the transformer. That's why they say don't ever touch a down power line, because the down power line could be 110, and if it is, it's probably not going to kill you. Or it could be way, way, way higher than that and have way more amperage, which we're going to talk about later, because the one going to the transformer is higher amperage and higher wattage or voltage than what comes into your house. That one you can get killed for being close to. If it hits the ground and you're too close to it, you can get killed.
That's why they say, like, if you're in a car, right?
Yeah, you get
Wires,
away.
you're not supposed to get out.
Yeah.
It's like the electricity would be like a million amps.
Okay, so it's a transformer rectifier. It rectifies it from AC to DC and transforms it down to these 3 voltages. Man, that really hurt my brain first block, but I couldn't think. Rectifier. Could not. That word wouldn't come into my head. I would have just failed my flight check. C-149, just we had to know which rectifiers were. Anyway, so AC wall outlet, DC is what we need inside the PC. Okay? And we have some terms when it comes to electrical power. First of all, we're going to talk from here on out in DC voltage, because that's what our computer uses, other than the fact that it's coming in AC. Okay? Voltage is potential. It's how much voltage defines how much power could come at you. Not does. Okay? How much could. Amperage is the current of the power, and wattage is total power. Ohms is resistance. It's on the slide, but I don't know. Calculating our stuff. But we need to know what watts, amps, and volts, amps, and watts are, and I'm going to give you my analogy. Okay, here's my analogy to understand. We're going to go to another slide. I didn't just go away. Plus, it's being recorded for you later. Okay, so we've got a pipe in our house. Okay, we've got our water pipe in our house, and I'm going to say the size of that pipe you should compare to voltage. Okay, the size of the pipe is like voltage. It is potential. By itself, nothing. But the amount that we're going to see come out of the pipe is defined by the size of the pipe. Amperage is the current or speed of the water going through the pipe. Okay? And then if we had a bucket on the end, fill it with water, and water in there, okay? The total amount that came out of the pipe, the water, or watts, equals total power, is defined by how fast our medium is moving through the pipe and how big the pipe is. Okay? So volts times amps equals watts. The potential, or the size of the pipe, multiplied by the current, or the rate that stuff's coming through the pipe, equals what we actually got out of the pipe, the total power, the wattage that came out of the pipe. Okay? So, when people say it's not the volts that kill you, it's the amps, really the potential isn't what hurts you, it's what current is pushed through that potential. It defines how much we actually got, how much electricity actually came out. So power supplies are divided by wattage, okay? This power supply right here has a total max wattage of 400 watts, okay? So this one that I was holding, has 400 watts. In other words, the total amount of power that it could give to a PC is 400 watts. No matter how many wires, no matter how much current, it can only give that much power. If it goes over that, it could start smoking. It could burn up, or it could just stop functioning altogether. Okay, if you try to pull more than what it's rated to pull out, because that's all it can push through. Okay, so that's my analogy. When you think of it, voltage is the potential, amps is how much current goes through at that potential, and wattage or total power is the multiplication of the two. And I'm going to give you an example of what I'm talking about. Okay, I have a hard drive on my PC. The hard drive is plugged into this plug right here. By the way, all these plugs are 12 volts, other than this big one, which is 3.3, or this little tiny one that's 5. Okay, so having said that, it's a 12 volt plug. Okay, so I know the hard drive plugs in at 12 volts, and I'm going to tell you that it's got a current of 3 amps. Okay, so if it's got a 3 amp current, how much wattage does it pull? How hard is that? Pretty easy, okay? So that's 36 watts of power that pulls, because we multiply the volts times amps to get the wattage. That's how much power one component in my PC is pulling. And when I go and evaluate power supplies, I have to multiply and add together all those wattages to say I need a power supply that is this big. Okay? Which is one of the hardest things that people have a problem with on this test. Is I will give you a list of components and say it's got this CPU, it's got this video card, it's got these memory cards, it's got this hard drive, it's got this motherboard, it's got this CD-ROM. What power supply should I buy? And I'll give you links. Should I buy this one or this one? And I'll give you questions that say how much wattage should I have? Because that's the biggest thing you need to get from chapter 3 is the ability to evaluate this to know I've got the right one. One of the big problems that happens with major manufacturers like Dell and any other one is that this case comes with this power supply. But when I go online, I can pick a better video card, I can pick more memory, I can pick a different CPU, I can pick another hard drive, I can pick all these different things, but that doesn't change. But maybe it should have. And so the biggest thing that I have ever replaced on people that buy their own machines is the power supply, because they don't change that, but they change all this, and then it burns out. Okay, so not an overly expensive component to change. But anyway, so when we're looking at power supplies, we need to make sure the total wattage is underneath that rated wattage. So my rated wattage on this one is 400 watts. I need to compare all those things that are in the PC and then look at that and figure that out. We're going to talk about that next week. Unfortunately, not in person. You're going to be watching videos that I have pre-recorded since I won't be here next week. But I want to do some hands-on stuff today, so which I can't do when I'm not here. So again, that's the same slide, but it's typed up for you right here. Voltage is potential difference in the circuit. Amperage is the current going through that circuit. And wattage is the total power that's coming out, which is calculated by volts times amps. Ohms is resistance, which you use to figure resistance of wires. When you're an electrical engineer, Max, you can go ahead and don't need to worry about resistance right now because we don't calculate any resistance in the class. This is one of those many things that are in the textbook that I'm like, doesn't affect your knowledge base to do what we do, so why not? Okay, do we have our notes? Can I continue on? Okay. So I already said this, I already did my analogy. I apparently did a different place in the other class. Voltage is the size of the pipe, amps is the flow going through the pipe, wattage is the total amount of power that comes out of the pipe. I just talked about it in a different place during the first block. Okay, static electricity. We're going to talk more about volts and amps, but this is where it falls in here, and really where we're talking more is going to be application of how does it affect my PC. Right now we're talking theoretical stuff, kind of. Static electricity is the difference between this different potential electricity between two objects. I'm sure that Peyton has run around, shoved his feet on the static floor and gone up to Madison and gone like that and shocked her. I'm sure he's done that to his little sister. Isn't that her name? Did I say it wrong?
Oh, it's
Maddie.
Is it Madison? No, it's just Maddie?
Madeline.
It's Madeline, okay.
Well, I do. I always no. I usually
I knew it
talk
was
my
Maddie, but
brother.
I guess I
I usually try to stop my brother.
Oh, you do? Okay.
He's
So,
one of the
I
best.
used to, I had a younger sister, we had a check carpet around, and I had shocker, okay? That could ruin a PC. Okay, the change of voltage between you and this PC, if I'm touching the wrong component when I do it, or electrical component can ruin it. I have ruined electrical components when I was down in Florida and I got put in charge of the IT department and I'd never even been inside a PC before. Literally, I'd never opened a PC. I was a programmer. We don't go inside PCs.
Now you are all the time.
Now I'm all the time. I never ever opened a PC when I got put in the IT department. I got put in charge of it because I had a computer science degree, and therefore you must know everything about computers. No, I didn't. So it was the best thing that ever happened, right? I would never be able to do this job because I'm the kind of person that when I get a job, I learn how to do the job. But in the beginning, yes, I ruined a couple PCs. I didn't know that if I just stuck my hand in a PC, you could ruin it. I found that out. Okay.
Did you ruin any of your body parts?
No, nothing like
Yeah,
that.
it says
So, there-
he lost his throat.
Okay,
I mean,
so there's some voltages you need to know. I should clean up all the sheets, and nobody was even looking.
that was
Okay, so there's voltages when you have static electricity. There's different voltages when you feel it. You know, you shock somebody and they go, ow. When you hear it, when you hear the crack, or when you see it, love to do it at night and actually see the shock when you shock your little sister, right? There's different voltages. So the voltage to feel it is 3,000 volts. You have discharged 3,000 volts. Almost no amperage, or they'd be dead. Okay? The 3,000 volt difference if you can feel it. Which means that if I touch this and I didn't feel anything, how many volts could I have just displaced into it and not known?
2,903.
2,999, right? It's going to be 3,000 to feel before I feel it. So just because you didn't feel anything doesn't mean you didn't do anything. Which is the point of you knowing these numbers.
What would it feel like if you
Just like when you shock your sister. It's the same thing. Or your little brother. Yeah. The same thing. Okay? The exact same thing. Okay? To hear it, you have to discharge 6,000 volts. And to see it, you have to discharge 8,000 volts. 8,000 volts. You know what the normal voltage is from an old TV? Anybody ever do that? You see the shock?
Yeah.
The normal discharge was 20,000 volts on that. Old monitors could ruin PCs. Did that too. Okay. Where I had the PC unplugged, but I didn't have the monitor unplugged. Okay. And when I was working on it, I unplugged it and then plugged it back in, and I saw the spark when I plugged it back into the video card.
So I mean, it was over 8,000.
It was over out 8,000. I did some research and said normally it's 20,000.
Jeez. Have you ever been in bed?
No, but it didn't work.
Then you pull it off your head, and like your hair will be on the blanket. When you pull it off, you can see like all the little sparks.
Yes.
It's amazing.
So these
Yes.
numbers will be on the test.
Right.
Guaranteed numbers on the test. Guaranteed matching numbers on the test. Guaranteed. If you don't have these written down on your piece of paper, I'm just guaranteeing you that you're going to see that matching number on the test. Or something like it where I said, I just touched my motherboard and heard the crack. What's the minimum number of voltage that I just discharged into my motherboard? So we do some things to keep this from happening. What?
Were you taking the test next week or will it be?
No. I'll give you the lessons and the test while I'm gone. I'm just going back and evolve it.
And then,
Next week is the last week of the quarter too. I already said I'd never give you the
Oh,
test.
snippety snap.
I don't want to retake that test. So I still
You can retake it, yes. You just have to come in.
Do I have
Do I say
to?
email
Can I just
you or-
retake it?
Yeah. My tech students are going to email me that you came in during enrichment.
So I have to come in and intervention. I just can't just take it again.
Absolutely not. That's the whole point of having
But I know what I got wrong because I only got 2.
Okay, and so you have to come in during intervention and sit here and
I
pay your
came in
fees.
yesterday.
It's not a free pass. You still have to pay for the ticket. Okay, so that's that. So we do some things to protect ourselves from ruining components with static electricity.
Where?
One of the things we can do is we can use a grounding bracelet. I can show you a picture of that, but it's just a bracelet that goes around your wrist, and it's got a little alligator clip that you clip onto a metal part of your PC. That's one way you can protect yourself from static electric shock when working on components. I don't have any of those. You can also use a static mat that the component sits on, and you just have to touch the mat when you walk up to it, and we have one of those in school that the school PA system is sitting on, and I don't have any of those either. Okay?
What do you use?
Everything, I'm gonna get to it. We also, every component that we get comes in an anti-static bag, like those video cards that are sitting up there. That's what those bags are for. They're just not nifty plastic bags that are static shield them. And this is what we do here at Trail right here. Every time we come up to a PC, if we're going to work inside the PC, we make sure the PC is unplugged. We hold down the power button for 20 seconds, dissipate any electrical power built up inside the PC, and we grab the power supply. If we walk away from the computer and grab a component, and we come back with the component, we grab the power supply. The power supply is connected to everything inside this PC. They're all wired together. The power supply is the hardiest component inside this PC. You will not ruin your power supply by shocking it. So every single time we come up to a computer, we grab the power supply. If you're sitting here talking to Max, smoking and joking, whatever, or looking at our PC, and I come back to my PC, I touch the power supply. Okay? Touch the power supply. If Max comes up and talks to you and he accidentally touches you, did you just change your static electricity? Yes, you did. Now you're equal with Max. Maybe Max was the same as your PC. So touch your power supply. Got that down? I've never, ever, ever ruined a PC since I started touching the power supply before I got inside. Nothing was ever done. I will tell you that where I worked in Florida, I had shag carpet. I didn't build
the
the building.
90s?
The area, it was just an old building
I tried to get
we were in, and
That carpet? You think that'd be just like concrete floor?
carpet.
it was second floor. We were up on the second floor, and it was all carpeted. Anyway, so it had carpet. You build static electricity faster on carpet, which is to say you don't build anywhere else. Just so if I was asking you on the test, the first thing you test for touching anything inside of PC, the answer would be the power supply. Should be right. Okay, we've got our electrical outlets. And electrical outlets, if it's wired correctly, which you cannot assume ever on any house unless you do the wiring yourself and been inside the wiring. This is the way it's supposed to be wired. The big prong is supposed to be neutral. You could stick a fork in it and you would not get hurt. Theoretically, I would not do it because if you didn't wire the house, you don't know that it's neutral.
I did wire one.
Okay?
Did you?
Me and my grandma.
Great.
The little one is the hot one. Okay? Why would they make the little one the hot one? So you can't stick a fork in it. Okay? So the smaller one is the hot one, the bigger one is neutral. For colors, if you use colors, the little one is black or red, depending on the wiring, and the big one is white. Okay? And the last one, the ground one, the one down here, is just plain copper, no shielding on it whatsoever, and it's the one that goes to ground that's supposed to be grounded. On old houses, there was no ground. My old wiring in my house, nothing upstairs is grounded. It really stinks. Okay, there's 3-prong outlets on everything. It's an old 1920s house.
What do you
Knob and tube. You can't do anything except for rewire. You know how hard it is to rewire the second floor of a house? Yeah, not doing it. So we don't have anything really expensive plugged in the second floor. I shouldn't say that. Drew and Josh's room are new rooms. They have new wiring. They have ground. My room, this old room, does not have ground. Okay. Without the ground, then the power supply is in the PC. I took my power downstairs. Is even more susceptible to electrical fluctuations. That third plug right there in your power supply goes to ground, so that your PC is always grounded. If you have electrical wiring that does not have that, or like my house has 3-prong outlets, but there's nothing plugged, nothing wired to that, then plugging in a 3-prong doesn't do anything, and there's no ground, which means surge protectors don't work. It means you have no grounding protection on those electrical plugs. There's a
I think in my house, like the
So, I'm just saying you might want to look before you shove a fork in your electrical wire. You might want to
Or we
know
can just not.
that you have good wiring.
It's also possible.
Or not shove a fork in it. That's a good idea too. I think we should go without it. Okay, so I have to have this ground for some of my electrical stuff, like surge protecting to work. That's part of this chapter 2 because we're talking about electricity. We'll get to that later. Okay, so there's a grounding strap. This looks like it's plugged in, but it's plugged in with a wire that only has this on it. So it's basically this plug on the computer. They have those wires just like a regular computer one, but these aren't there, just so you can have your computer grounded to the local ground as well. So that's a grounding strap. That's, I don't know why it's not a real picture of a map. You do have one of those downstairs. That's an anti-static bag. So when we're looking at a power supply, this one is 3.3 volts. You will need to know this. This will be on the test, guaranteed. Okay? I'm going to say what is the main P1 power connector voltage. That's the main P1 power connector. P1 going to the motherboard. The main P1, the big one. Big main P1 power connector. How many volts is it, Brighton? How many volts? 3.3. Austin, how many volts is it? Max, how many volts is it? Peyton, how many volts is it? Okay, all the other main plugs, and I don't have pictures of all of them on here, but I do in my hand right here. All these other ones, whether they're regular Molex, which is what this one's called, a Molex plug, or the new SATA plug, all these are 12 volts. Okay, all the other ones are 12 volts. So, if I showed you that plug,
Oh, you said one was 5.
I haven't gotten that yet.
Wait, why?
No, I don't want to write down all other ones are 12.
Except for the little one that goes to the floppy drive is a 5 volt. Okay?
Why is...
So this one's 5. This one's 5. The floppy one's
Why is...
5. But the voltage coming out is 3.35 and 12. So I'm going to ask you a question like this. I'm going to say, I have my CD-ROM plugged in, and it's pulling 2 amps. How many watts is it pulling?
That's 2 amps.
How many watts is it pulling? Based on what I just said here,
It's 3.3.
It would be...
I just said it was pulling 2 amps, and I asked you
I don't
to
remember
tell
what you said you
me
plugged it
how
into.
many
What
watts.
did you plug it into? CD-ROM? It would be...
How many watts?
6.6.
Everything is plugged in is 12. 12 times
No, no.
2
It says plus right there.
24.
It says plus right there. It does say plus, so that's why I said 14.
Well, that was stupid. I already told you both times with watts.
And I was like, why are we adding now?
We are adding it. So that was my.
I knew it!
I didn't finish my multiplication sum. Okay, volts times amps equals watts. So if I just give you amps and ask for watts, you need to know the voltage yourself. Because I shouldn't have to give you that part of the problem, because you should already know what it's plugged into. Fish?
Yeah.
Okay, I'm going to ask you that on the test too. So we got 5s, we got 12s, we got 3.1s. The only one that's 3.1, alright, sorry, 3.3, I just said 3.1. 3.3 is the motherboard. Pretty much everything else I'm gonna ask you is 12, including this P4 connector that goes to the motherboard. That's a 12 volt as well.
We really cover anything on the 5-volt floppy.
I could, you know it. Okay. So same thing, different picture. I got 3.3, 12s and 5s. This one's not used anymore. That was an old AT power supply plug there. And we're not going to go on from here. I'm going to say that right now we're going to stop and do some hands-on, go downstairs for the last 20-some minutes of class. What we're going to do, because I can't do this while I'm not here, is that we're going to pull power supplies, we're going to test power supplies, we're going to put power supplies back in cases so you get hands-on of how to remove the power supply, how to test the power supply, and how to install a power supply. Next week when I'm not here, we're going to do the lectures on, and you're going to watch the videos, you're going to take little mini quizzes over the videos to make sure you got it. I'm going to teach you about UPSs and UPSs, UPSs, and power supplies, surge protectors, and stuff on power protection, and then teach you how to calculate the wattage requirements of the power supply. What? You can, yes, because we don't need to come back up here. Yes, Mr. Brighton.